This series of presentations will help you understand what is happening behind the curtain when you use the Internet. In this presentation, we'll examine the Domain Name System protocols, or DNS. All packets of data sent over the Internet are addressed using the IP numbering system. Domain names like www.company.com must be looked up in the domain name system so that data can be sent to the right computer. How does your computer find out the IP address for www.company.com? It uses the DNS protocols. The DNS protocols say what zeros and ones to send, when, and to what computers to get that IP address for a domain name like www.company.com. So what are protocols? They simply tell you what to do and when. Humans have protocols too. When you meet somebody, you shake their hand. People vary as to the protocols they follow. But with computers, there is less flexibility. A protocol is specific. Protocols change over time, sure. There are organizations that debate and adopt new versions. These are decisions made by people. Protocols often are compromises between competing objectives: security, bandwidth, reliability, privacy. Compromises made at a particular point in time. The compromises embedded in protocols affect the consumer and the citizen. In 2013, some of the most central protocols are provoking international controversy because of their implications for democracy and commerce. Protocols allow us to climb the ladder of abstraction and not worry about the details, but the details are important. These protocols allow us to collaborate across computers without worrying about the details of how the computers are connected. So how does the domain name system work? Domain names are coordinated by ICANN, the Internet Corporation for Assigned Names and Numbers. Names are in a hierarchy, forming a tree. At the top of the tree is the root. Now, ICANN is a nonprofit organization. Together with governments, universities, and other organizations, they control the root. But they do not keep a centralized control on domain names. They delegate the authority to create domain names to the owners of top-level domains like .com and .org. The owner of a domain has the authority to create as many subdomains as they wish. In this diagram, the owner of .org has created two subdomains, fun.org and example.org. If the owner of a domain wants to, and they often do, they can delegate authority to these subdomains to create even more subdomains. In this diagram, .org has created fun.org. The owner of .org can create the subdomain www.fun.org if they want, but they are more likely to delegate that authority to the new owner of fun.org, who can then make up subdomains within fun.org as they wish. This system of delegated authority makes it easy for the system to get bigger and bigger without problems that would arise if a central authority had to manage everything. The system depends on name servers. There are two kinds of name servers, authoritative and recursive. We'll come back to the recursive name server and concentrate on the authoritative name servers for now. Each domain can have its own authoritative name server, or multiple redundant authoritative name servers, to tell the world what IP addresses to use for domain names in their domain. Each name server only needs to know the IP numbers for the domains immediately below it. If the domain has delegated authority to those subdomains, then the IP numbers it points to are just additional authoritative name servers. Name servers also know IP addresses for computers that you might want to reach at a particular domain name. If you were trying to reach fun.org, the .org name server will tell you the actual IP address of fun.org, because fun.org is right below the name server in the hierarchy. Fun.org might have multiple redundant IP addresses, and your computer would just pick one to which to address your packets to fun.org. But if you were trying to reach www.fun.org, then the .org name server will only tell you the IP address of another name server you should ask, lower in the hierarchy. That name server, the fun.org name server, will tell you the IP address of www.fun.org. The name servers themselves have domain names. They often use NS for name server as part of their domain name. As you can see in this example, more than one domain name might point to the same computer. A single web server might host many websites with many different domain names. Whenever a web browser looks up any of those websites, they get the same IP address for the same web server. So that finishes the first half of the domain name system, the hierarchy of domain names and of authoritative name servers that can delegate authority. But how does your computer get the information? That's the second half of the system. Your computer starts out with the IP address of a recursive name server. If you want to reach www.fun.org, a flurry of packets are exchanged. Each packet zigzags around the country through multiple computers along its way. Each arrow in this diagram might involve many computers. Your computer asks, what's the IP address of www.fun.org? At the bottom of your browser, you see, looking up www.fun.org while you wait. Your name server, that's the recursive one, asks the root name server, who replies with the IP address of the .org name server. The recursor, yours, asks that name server, who passes the buck again. Your recursor asks again, and finally gets an answer. Your recursor passes the answer back to you, and you finally send your web request to www.fun.org. To speed things up for the next time, your recursive name server keeps the information in a cache. The downside is that any information that is outdated or maliciously wrong keeps getting used. This has been used in attacks on the DNS called cache poisoning. You might have wondered, how can your computer talk to the name servers or the web servers with just zeros and ones? Now that you know how domain names get turned into IP numbers, we'll dive deeper down the ladder of abstraction. The next presentation in this series will dig into the zeros and ones used for sending any packet over the internet.